In ancient history, creating software involved a lot of manual labor. You'd invoke compilers by hand, run tar manually on a bunch of compilation products to create your software bundle. And more sophisticated engineers might have been hand wiring their dependencies in a makefile. Maybe some of us still do that, but generally that involves a lot of manual labor. Yeah, the one way out of this was the IDE, the Integrated Development Environment, which would offer an interface for the whole software development lifecycle, like starting from editing, obviously, including automatic formatting, refactoring, giving you a structure to put your code into, organize it in projects and modules, and have a way to specify dependencies, building, running, testing, that whole stuff, debugging it, packaging eventually, and deploying. So all's great, right? Well, maybe not. I'm Justin, as I was introduced just now. You can also find me on Twitter as Ebenwert. You can find the IntelliJ Scala plugin team also on Twitter as IntelliJ Scala. You can tweet questions at me or just ask them during the talk as you prefer. If you're shy, tweet them. Or if you prefer a permanent record of them. By the way, who knows that, actually who is a user of IntelliJ Scala? Just to get an idea, yeah, most of you. Who knows that the Scala plugin is open source and on GitHub? It's getting more. Every time I ask, it's a little bit more. So, yeah, if you have any problem with it, one way to deal with it is to report an issue or just complain to us on Twitter. Another would be to actually try to fix it in the source code. We're happy to help out there. Anyway, I want to talk about something slightly bigger picture, integrating developer experiences, and specifically how we're trying to do that with the build server protocol currently. And I'll go into this approach and give some specifics of how the build server protocol BSP works and how it's implemented in the IntelliJ Scala plugin. Now, the IDE does all kinds of useful stuff, but it's on the desktop. You're kind of bound to the user interface. But you want all your tools to work in many contexts, such as on the CI server, on your command line, or in a graphical user interface, maybe even a web interface. And for that, yeah, we're back to one job tools that just do more or less one job, try to do it well. People disagree how well they do it, especially on the topic of build tools. Nobody really seems happy with their build tool in Scala, so we get a new one every month or week. And build tools have traditionally encompassed a variety of tasks, such as packaging and compiling and so on, and increasingly this is being split up into more special purpose tools, such as Bloop. Is Jorge here right now? He's somewhere around. He's been developing Bloop, which is a special purpose compile server. And yeah, we have test frameworks, and all of these tools aim to be more cross-platform so they can run in a variety of contexts. Now, I still want to use my favorite front end, namely IntelliJ, to work with all these variety of tools, because I don't want to learn a command line interface for each one of them. So traditionally, with IntelliJ, we've tried to make special purpose integrations for each build tool, test framework, sometimes even libraries such as Akka and Play. And each one of these integrations takes a lot of work, and there's a bit of a mismatch. You can see the interface here. The faces don't really match that well. So what are we going to do about that? But some more motivation first, like, yeah, build tools in Scala have this problem especially. We have several choices besides SBT. There's the classics, Maven and Gradle. There is new ones such as Mill and Fury, and there is more general purpose tools such as Bazel. All of them are being used in the Scala ecosystem. And for them too, I want a common front end. And yeah, you see we have a bit of a tangle of tools here. There's lots of haphazard integrations. If you've used SBT with IntelliJ, that's the thing I've worked a lot on myself. You might see, okay, it kind of works, it's usable, but maybe you're not entirely happy with it. I know I'm not. So the parts are sort of tangled together, but not very coherent. And I've been working on tying these loose threads together to create a more integrated developer experience. But before I get to the build server protocol, a bit about the prior art, the language server protocol, which inspired BSP. This was developed by Microsoft for the Visual Studio Code editor to make it easier to integrate all the languages with the editor VS Code, and now many other editors as well. The basic concept is we split up the language support into a client, the editor, and the server, the language server, which knows how to compile sources in a given language and which can send, say, compilation errors and so on to the editor. And the editor knows how to display this. This is a different approach than what we've been doing in IDEs, especially IntelliJ typically. In IntelliJ, the language model is built into the IDE. So if we want to support a new language, we need to write our own parser and type checker and other components for each language. Now, the LSP has been very successful at what it does because it makes it much easier to create language support for a variety of editors. So people have been asking us, when are we going to use it for supporting Scala, especially Scala 3, which already has an LSP server available? And, well, the answer is probably maybe never. But why? So I've mentioned, yeah, we need to create our own language model, and all our intelligent code editing features such as refactoring and going to definitions and other stuff we're building like data flow analysis and so on. A lot of this depends on having the whole language model available in the IDE. And LSP doesn't offer this richness. So with LSP you get a long way, but you don't get the full way that we want to support languages. So we're stuck with duplicating a lot of work. Another reason is, like, LSP doesn't really model the structure of the code base, which is also a thing we do in IntelliJ. We have our own, we have our own model, project model, and there's also no common concept of build, test, run. So in LSP, the language server decides what to compile based on just user input, such as file save. Everything else, if you want to build the whole project or so, is more of a language-specific feature. But the main impediment to working with LSP in IntelliJ is indeed the model of the syntax tree, which LSP doesn't provide. Now, I mentioned a lot of build tools and how they come out every other day or so. So one of them is Fury, developed by John Purdy. John, are you in this room? No, he's outside chatting. He already saw the talk. Right. So this new build tool emerges out of the ground, and I'd really like to support it, but Fury doesn't really have a user base yet. It has more developers than users. Including myself. So I asked John, "Are you going to contribute IntelliJ support for Fury?" And he was like, "Maybe not." So I went ahead and implemented build server protocol into Fury, because I can't really justify adding Fury-specific support in IntelliJ, because that increases the complexity of our own code base a lot and adds maintenance costs. So I worked for like about 2 years on the SBT, improving the SBT support, and I noticed, there are always new little issues, corner cases to handle, working with different SBT versions. One SBT version breaks something that I use, and so there is a huge maintenance cost associated with each tool support. So I can't do that, but I could support a protocol that speaks with many different tools in a standardized way, which is hopefully more robustly. So I'm just going to show you. I implemented the build server protocol into Fury, and then I imported, here we go. Then I imported the Fury project, which is of course defined in Fury into IntelliJ, and voila, we have most of the features. We have it nicely defined as modules, like you see here, Fury dependency, Fury imports, and so on. We have all the files, and this is the BSP implementation in Fury, and I can easily navigate to definitions, or I don't know, rename variables, everything you can do in the IntelliJ editor. And that was with a fairly minimal implementation cost. It's like maybe a few hundred lines in Fury, a bit more in IntelliJ. Right. So that seemed simple enough, but so my thinking was like, there's some Abraham Lincoln quote, something like, "Give me 6 hours to fell a tree and I will spend the first 4 sharpening my axe." I thought, okay, give me 1 month to support a build tool, I will spend the first year defining a protocol. Because, the first working demo of the build server protocol was over a year ago. We've hence gathered some experiences with it, made the protocol more stable. Stable version 2 should be out very soon, maybe a month ago. That was the plan, right? And then we'll have the possibility to support many different tools, such as Mill and Bazel, without writing as much dedicated code for each of the tools into IntelliJ, and have a basic support for a given tool without writing any dedicated support even, such as the case with Fury here. Another interesting bit about Fury is that it functions both as BSP client and BSP server. So relative to the editor or the IDE, it acts as a server. And relative to Bloop, it acts as a client. So Bloop, the compile server developed by Jorge at the Scala Center, is also a BSP server and offers compilation as a service to any client that wants to use it. So that simplifies the build tool as well. Now, I want to go into a few details about how the build server protocol is defined, is designed. So, as the name already suggests, it's very closely follows the language server protocol in its definition. So it's also a client-server protocol based on JSON RPC. And it defines a couple of standard actions, such as build, compile, run, and a way to get the project model in a fairly generic format that can represent most build tools' project models. However, these generic concepts and generic model doesn't map perfectly to each build tool, and also doesn't map perfectly to the IntelliJ model, for instance. Now, I said it's a client-server protocol, but really it's kind of bidirectional, so both the client and server can send each other requests or notifications. Usually it's the client that sends a request, which engenders a response, and usually it's the server that sends a notification, which doesn't expect a response. Now, one interesting part is if we want to support a tool that we know nothing about, like IntelliJ knows nothing about Fury, how to start Fury, how do we connect to it without having any manual user configuration there? So we defined a simple protocol for that, and it works like this. The server, when you install it, either onto your system or into your project workspace, will write a simple little JSON file that describes how to start the server how to start the BSP server. It will be located at one of a few specified locations, so either in your project workspace or on your system, in a system-dependent directory, like your user directory. And then the client just can look for these files and read them and start the server. I think this is a concept that LSP doesn't implement in this way. No. Now the BSP server, the BSP connection, the BSP protocol has a few lifecycle requests and notifications. So when connecting initially, the client will send to the server an initialize request. The server will eventually send a notification, hey, I'm initialized. Then all the interesting stuff happens, and when they decide they're done, the client will ask the server to shut down, and when the client is then really done, it sends an exit notification to say, okay, you can close the server connection. Now, the more interesting stuff, build structure. So I said we have a fairly generic model of describing the structure of a build. We have a simple concept of build targets. I represent them here as these hexagons. And targets encompass some metadata, such as capabilities. Can this target be compiled? Can it be run? What languages are contained in this target? And associated with a target are a bunch of sources, which are basically just directories or files. And each target can depend on other targets. That just means, okay, to compile this target, that other target needs to be compiled. And the sources in this other target are dependencies of the sources in this target. If you see this here, any sources can be associated with multiple targets, and one target can be associated with multiple sets of sources. Then we have a bunch of actions, build actions, typically such as compile, test, or run. The most common will probably be compile or test. And it looks like this. You make a request, you add a bunch of build targets in this request to the server. The server will do stuff and eventually send you a compile result, meaning it's done. In the meantime, you will get in real time progress notifications and diagnostics. So the diagnostics are the LSP word for warnings, error messages, and so on. So which can then be displayed in your editor or in a list of error messages in the IDE. The progress notifications tell the client what is actually going on right now. So is this target that you're building taking forever to build? So it's much easier to figure out where a compilation might be hanging. A bit more about diagnostics. So these are implemented as notifications that the server sends to the client, and they contain errors and warnings, and they are very analogous to diagnostics in the language server protocol. Basically the same data structure. Also, as in LSP, you might have messages that are not bound to any specific file. The tasks look like this. So there are multiple notifications that can be sent independently, but typically they will be sent while a request is being processed by the server. It starts out with a build task start notification, which contains some ID. And then there might be multiple build task progress notifications, which refer to this task that was started at some point, and eventually a build task finish notification. Okay, that's pretty straightforward, I think. So I want to show you some of this in action. I already showed you Fury. Fury currently has a very basic BSP implementation, so it can't even compile. instead I'll open the akka project, which I've previously exported as BSP. You see it has tons and tons of modules, and I will run a build on that, and it failed. Oh, that's unfortunate. I should have tested this before, right? Let me just try a re-import. That was a little quicker than via SBT. Okay, here we go. We see here a warning count increasing quickly, and a bunch of you got messages here, 823 warnings, which we got nicely listed by directory. We have lots of green check marks, so we got updates for every individual module subproject in the akka project, how long it took us to compile, and if it completed successfully. Okay, this was not supposed to fail. I guess that's just a little bug I need to fix, because all the compilation finished correctly. And I thought I had let me try again. Here we go. I cleaned the output directory, and now you're actually getting these progress notifications and see where the compilation is happening. So akka protobuf took us 5 seconds. Akka actor is taking longer already. And that goes on, and you get the warnings live. So this is already a bit nicer than what you get with SBT, which is just console spamming text errors. Now, some of the challenges that went to this is mapping BSP targets to IntelliJ modules. So here I've got a little schematic, what happens when we have a SBT project, such as akka, and want to import it into IntelliJ via BSP. So currently this happens by exporting the SBT project to Bloop. Bloop acts as a BSP server, and then importing via BSP into IntelliJ. So SBT has the concept of projects. Projects has multiple scopes. I just listed compile and test here as an example. SBT can have more of them, but let's ignore them. If we export this to Bloop or as BSP, in BSP, target does not have multiple scopes. So what we do instead, we create multiple targets that basically just duplicate the information, such as class path and set of sources used in the individual scope. These targets, of course, will share some sources. And then when we start importing into IntelliJ, IntelliJ also has the concept of scopes, but IntelliJ only knows about compile and test scope. We're more limited in that way for, I guess, historical reasons. And we have another important limitation. We can't support multiple source directory. We can't support sharing source directories between modules, because each source needs to be associated with exactly one module. That makes everything much more troublesome. So the way around it we use right now is, okay, we have these multiple targets, such as a compile and a test target, which happen to share the same base directory. So the heuristic we use is, okay, if they share the same base directory, they probably can be mapped to a single module in IntelliJ. And then we just take the compile target and map it to the compile scope in the IntelliJ module, the test target and map it to the test scope in the IntelliJ module, and we've basically recreated, in a roundabout way, the SPT project. However, if the SPT project uses more scopes, such as integration test or something you made up, then that just won't really work very well in IntelliJ, so don't do that if you want to use IntelliJ, sorry. Shared sources, also a big issue. You see them a lot with cross-platform projects, such as Scala.js plus JVM projects. You often want to share some sources. Yeah, IntelliJ doesn't really support that. So what we do is, if we detect some shared sources, we just plunk them in a module of their own, and depend on this module you see here from the natural modules. They depend on this synthetic shared module. That kind of works as long as that module doesn't have any strongly differing dependencies. So say if this left one here was a Scala.js module, and this right one here a JVM module, they shared one set of sources, then we just merge the dependencies of these modules and declare it as the dependencies of the shared module. And yeah, sometimes that works, but it's a common case where you will have weird error messages highlighting errors in IntelliJ. So we're still trying to find a good way around that. One way may be supporting it on the build tool side. So Fury has a concept of schemas, where you could have a different schema for JS or JVM, and you could switch between these schemas and quickly do a re-import, and then this would be less of a problem. Right, I've already showed you how the compilation looks, so let's just skip this one. So that was the basic overview of BSP. Now we have a bit on the roadmap of what we want to do. So I mentioned the 2.0 protocol is right around the corner, a month ago or so. Tomorrow, whatever. We're coordinating with the Scala Center, so Bloop and Metals. Right, we're coordinating, Olaf? Yes, yes. Olaf here wrote down the original spec of the build server protocol, and we've been working together on it since. And at that point, it will be easier to add new build tools, such as mill, and support them via BSP. The support in IntelliJ itself is still still roughshod, so it will only support Scala at this moment, but that's maybe one of the easier parts to extend. The overall robustness is maybe not what you'd want, and it currently supports only compilation via BSP. That's not horrible because we already have built-in support for most common test frameworks, but of course we'd like to be able to do that via BSP as well. Now the title of the talk was Build Server Protocol and Beyond. I have one slide going beyond. So what else could we do besides integrating build tools? There's many other targets that might be interesting to support via standardized interfaces or protocols. So one thing we have been sort of looking at in BSP is building things remotely. So if you could have a build server, an actual server running remotely that you let do the heavy lifting of compiling stuff and running tests. Because currently BSP is mostly focused on local building. There could be other tools such as code formatters, which could have a standard way of being addressed by the editor. And I don't know, maybe other things you can think of that have been hard to integrate, or that have differing interfaces that you use via command line, and you'd just really like to click one button because that's all it would take ideally. Now, the challenge with making protocols is, of course, first of all, adoption. If you have a protocol that nobody adopts, you might know this classic XKCD. You have 15 competing standards. I'm gonna make the standard to rule them all. Result, you have 16 competing standards. So that's why I'm talking to you right now, so you maybe buy into our idea here. And now, even if you define a protocol, it might not be generic enough. So with build tools, we have a set of actions that are really common across build tools. So it makes sense to define a protocol, but that might not be the case for every use case you can think of. Okay, that's all I really wanted to tell you today. But if you have any comments or questions, please do ask, tell. Yes?
Do the protocol implement a file server so that I don't have the file server?
Excuse me, the file server. So was the question that the build server protocol? No, it doesn't include a file server protocol. Do you mean this would be interesting for?
I mean, files are referenced as URIs, but it doesn't define how you read a resource, for example. So it's left for the
So yeah, just to repeat it for the microphone, files are referenced as URIs. It doesn't define how you read them. So in principle, you could read remote files as well. So it's already specified that they are URIs. But like the implementation in IntelliJ, at least currently assumes they are local. Yes?
You mentioned testing through BSP.
Mm-hmm.
Is there any support for a data mode for test suites and test cases and successful things?
Okay, testing in BSP. Yeah, there's a request for testing a certain area, certain target. There's some Scala extensions for giving you classes which can be tested. And the progress API defines some way to tell you, okay, this class or this test is currently being run, and this has completed with an error or with a success. So it's already covered by the protocol, yes. Any more comments? Yes?
Can we cancel some requests?
Yes, requests are cancelable.
Last time I tried,
You tried it with BSP or with Bloop or with Bloop? Yeah, I might have not implemented it correctly yet. So, yeah, I think there were some points where I didn't implement the cancellation yet. But I take bug reports, and that means it's important to someone if someone reports a bug, so it helps me prioritize. Yeah. Any more? Okay, we're out of time, I guess. I'm around, talk to me. Thank you.